What problems can the heaviest stack in the time profiler help address? So the heaviest stack section in Xcode Instruments Time Profiler shows the most CPU intensive call during profiling. This helps identify the most resource heavy functions running in your app. Below are the types of problems it can address. High CPU usage and performance bottlenecks. The heaviest stack reveals which functions are consuming the most CPU time. If certain functions appear at the top of the heaviest stack repeatedly, they are likely causing CPU overload. Common culprits, inefficient algorithms, excessive recursion, unoptimized loops. And the solution is usually to optimize expensive computations, use caching, and reduce unnecessary function calls. Main thread blockages and UI freezes. If functions in the heaviest stack are running on the main thread, they can cause IG lag or unresponsive interactions. Heavy operation on the main thread might be blocking animations, touch events, or rendering. Large synchronous file operations, complex JSON parsing, long-running database queries. Solution: to move expensive operations to a background thread using dispatch queue, quality of service.background, async. Okay? Inefficient loops or repeated method calls. If the same function appears multiple times in the heaviest stack, it may be running unnecessarily often. Common causes for or while loops with excessive iterations, did set or will set observers triggering too frequently, redundant view updates in draw or layout subviews. Solution: optimize loops, debounce observers, and prevent redundant UI updates. Expensive rendering and animations. Core animation functions appear in the heaviest stack. It means the app is spending too much time rendering graphics. Common issues: overuse of CA layout or draw, unoptimized UI collection view or table view cells, excessive auto layout calculations. Now, with that being said, in this tutorial, we're using SwiftUI, not UI kit, so we won't have UI collection view, UI table view. Okay, but we can reproduce some of this stuff using lists. So the solution should be to use should rasterize for static layers, batch updates in table views, and avoid unnecessary relayouts. Poor multi-threading or thread contention. Core animation function appear in the heaviest stack. It means that the app is spending too much time rendering graphics. Common layout issues: overuse of CA layer or draw, unoptimized UI collection view or table view cells, excessive auto layout calculations. Solution: use should rasterize for static layers, batch updates, table views, avoid unnecessary relayouts. Slow network requests affecting app responsiveness. NSURL sessions or NSURL connection functions appear in the heaviest stack. It means network calls are delaying execution. This is common when large API responses are processed on the main thread. JSON decoding is inefficient. Synchronous network requests block execution. Solution: move network calls off the main thread and process API responses asynchronously. Excessive memory allocations leading to CPU spikes. If malloc, free, or object C retain functions uh, dominate the heaviest stack, it means memory allocation is causing CPU overhead. Common causes: creating too many temporary objects, excessive use of NS data or UI image in loops, retain cycles, leading to excessive object allocation. Solution: use memory efficient data structures, cache expensive objects, and eliminate retain cycles. So, again, what can the heaviest stack help fix? High CPU usage. Okay. Um, it can help fix main thread blocking, inefficient loops, rendering and animation issues, multi-threading problems, slow networking calls, excessive memory allocation. Okay. And these are the solutions, right? You can optimize algorithms, move work to the background queues, optimize loops, reduce redundant execution, optimize rendering, batch UI updates, reduce thread contention, use concurrent queues, move API processes off the main thread, optimize memory usage, avoid unnecessary allocations. So we're going to get into some examples. But before we go into examples of this, I'm going to have to make a sharp turn and discuss one thing that we must understand before we use heaviest stack, and that is DSYM and symbolication, and because it's necessary to set your DSYM files up and use symbolication so that you can reference inefficient functions instead of memory addresses. And you're asking me, what is that? Well, I'm about to explain. Okay. So, yeah, on to the next.